So let's have a look at the first function here. If we, for example, want to set up on PWM7 here, the gyro on-off function, we just click PWM7 input here, and here we can select whether we want the gyro on-off function to work on the pitch, roll, or yaw axis, or all of them, or any combination of them. Note that you can't click any of the checkboxes on the left-hand side, they're automatically checked for you. Now if we wanted to input gyro 2 gain adjust on PWM-in2, we simply click here. What this does is it allows you with a RC transmitter input to be able to flick the gain between two different settings. What you're actually doing here is you're adjusting the gain from the basic gain that's set up in the Professional 1 tab. Here you have a gain for each axis set up here on these boxes here, and what you can do here is you can multiply those gains by a factor. So you can increase those gains, say, by a factor of 1.6 for the pitch, 1.5 for the roll, I don't know, 1.7 for the yaw, with the flick of an RC switch, which is connected to input PWM input 2. This is useful for aircraft flying when you want different gain settings, typically when the aircraft is flying at high speed or when it's flying at low speed, or if it's a 3D aircraft and you want to do hover, you want very high gain, and then when you want to fly at normal speeds, then you want to reduce the gain dramatically. Now we also have a rate adjust box here. Normally the rate is set by default at 250 as a maximum range, maximum 250 plus or minus 250 degrees per second as an acceleration that the gyro will measure. Now this can be adjusted to 500 or 2000. This may be interesting if you're flying in extremely bad weather conditions where there's very strong winds, a high level of buffering. Then you may want to flick the gyro onto a much higher range setting, so the gyro can still detect these high accelerations and correct for it. So that's the gyro 2 gain adjust. You can also set here an exact gain adjust. This for independently also on pitch, roll and yaw. This function is detailed in the user manual and basically allows the gain to be adjusted by an input from the RC transmitter. So the RC transmitter input can be set to any value from an RC lever minimum position to a maximum position, and then the actual pitch used will be based on that. Let me just bring in the document, the user manual document, and you can see here that by setting the value 2, for example, then if you look at the PWM being input, maybe it's 20% of its full range, then the gain factor becomes 4.56. So this method of combining a setup value here and the PWM input here means that very many different gain settings are achievable. As I said, more details in the user manual. We also have a gyro PID target here, which we can set. For example, we can put this onto PWM input 4. So then this allows, at the flick of a switch, the RC transmitter switch that is connected to PWM in 4 can be switched on and off, and the rate about any particular axis can then be programmed in here. So you may want a pitch rate of 25 degrees per second whilst the switch is flipped in the on position, and then as soon as it's switched off, that pitch rate will disappear. This might be useful if you wanted to flick a switch and allow the aircraft to do say a 360-degree roll in exactly a given time. Then you could set the pitch and the yaw to be 0, and the roll rate you could set to be, say, 100 degrees per second, and then given this rather high roll rate, your aircraft can perform a roll in about 3 to 4 seconds. Another function down here is Z, mix into X and Y gain. This is used for quadrotor applications, where it's necessary to mix the yaw signal as measured by the gyro into the pitch and roll motors for the quadrotor, so that the yaw stability is achieved. Power in mode, we have a power in mode function here, which means you can have power in, and it can be mixed into pitch and roll, but this will only happen if in the basic tab we have the quadrotor mode set. Otherwise, in aircraft heli mode, it makes no difference. So we can just leave these as they are. For aircraft or for heli mode, power in is useful. If power in is coming in on input, say PWM in 6, and we have in the basic tab set up power out on PWM out 6, then it will be affected by whatever curve is selected in the power curve section. You may want to select a cube curve, for example, which will look something like this. And then we can connect the actual heli output, or rather the gyro power output, PWM out 6, to the heli motor control. We have an emergency cutoff, which we can implement here. For example, on PWM in 2. Now, if no PWM signal is applied to this PWM in 2, or if a signal for some reason stops, then all the output PWMs will go to their default values. In the aircraft mode, this is in the for these outputs to be put into their central positions. So effectively, pitch, roll, and yaw control surfaces will all be centralized. We have an eye adjust, a heading lock feature here, and what this allows you to do is to put in a gain value here, and for pitch, roll, and yaw. And so if we look at the pitch, for example, if you require a certain pitch, if that for whatever reason you have too much pitch over a period of time, then the heading lock feature will slowly try to reduce that pitch, so that your pitch is over time average, pointing in one direction only. The same goes for the roll and the yaw axes. We can select input power curve to be switchable. So for example, the input power curve by default, when this RC transmitter switch is in the off position, will be whatever has been set up here, and for pitch it's linear as shown here. Now you may therefore want to switch that to another type of curve, for example sigma medium, in real time. Input pitch curve is also a similar function, operating on the pitch curve. So if we look at the curve, this is more useful for helicopter. You may have a helicopter pitch curve like this, medium, and you may want to switch to this curve. So that's achieved here where we can set this to helicopter pitch medium, for example, and then when the RC transmitter switch is flipped that's connected to PWM input 2, then the curve will flick from its default position as seen on the curve section to this new position, this new curve. So these are the real-time programmable inputs, and more details obviously are available in the user manual. This page also can be set to its default values by simply hitting the default button.